10.3, geometric sequences in series. A geometric sequence is a sequence in which the ratio between successive terms is a constant, the constant ratio. So when we looked at arithmetic, we were looking at a constant difference. So we had adding and subtracting going on between terms. With the ratio, we're going to look at what we're multiplying by to get to term from term to term. Multiplying or dividing, really. If we multiply by 1/2, it's the same thing as dividing by 2. So you could think of it as both. So for our first one, we're just looking at determining our common ratio and then finding the next 3 terms. So when we were looking at arithmetic, we took like our second term and we subtracted our first one. So now when we're looking at geometric, we're looking at dividing. So I'm going to take 9, my second term, and divide by my first term, -6, and I get -1.5. And then I want to go ahead and check it with term 3 and 2. So I'm going to take the third term, -13.5, and divide by the one before that, 9. And I get -1.5 again. So what that means is I'm taking each term and I'm multiplying by 1.5 in order to get the next one. So it means that my common ratio is -1.5. So in order to get my next one, -1.5 times -13.5 is now positive 20.25. Multiply again, -30.375. And then the next one would be 45.5625. So again, when we were doing arithmetic, it was what are we adding or subtracting to get the next term. Now when we're looking at geometric, it's what are we multiplying or dividing to get to the next term. So just like we have kind of a formula for an explicit arithmetic sequence, we have the same thing for geometric. So we can find our nth term using A1 and R and this formula right here. So now we're going to practice using that in different ways. So the first is just to write an explicit formula and also recursive too. So we'll look at both of them, just like we did yesterday with arithmetic. We're kind of doing all those same things over again. So in order to have an explicit formula, I need A1 and R. I have my A1 right away. That's -1. R I would get by dividing those terms out again. So 2 over -1 is -2. And I always like to check using the other 2 terms I've given. -4 over 2 is also -2. So I have A1 and I have R. So now I'm going to go ahead and write down my formula and now plug in my values. A sub n equals A1 is -1 times R. Notice I'm putting R in parentheses because it's a negative. I have to have those. And with arithmetic, we had some simplifying to do. With geometric, we don't. We're just going to leave it this way. So this is my explicit. For recursive, I always like to start out by thinking, what am I doing each time to the previous term? So this is really has to do with that common ratio, or if I'm doing arithmetic, common difference. So I am multiplying by -2 each time. So multiply previous term by -2. It just helps me to think about this in words. And when I write a recursive formula, I always start out with whatever my a sub 1 is, and that's -1. And then I find a sub n by taking the previous term and multiplying by -2. And if I'm looking at an, the previous term would be a sub n minus 1. So -1 would be the term that comes one before that. So I want to take that previous term and multiply by -2. So now we've got a recursive formula as well. So for 3, we're going to find our 11th term. And we don't want to do this by just continuing to multiply. We want to do this by coming up with a formula and then saying, here's what's going to happen when n equals 11. So first we'll write our formula. So remember, this is what we need. A sub n is A1 times R to the n minus 1 power. So I know that I'm going to be finding my 11th term where the n is 11. But for now, I need to do the same steps I did in the last one. My a sub 1 is -122. And I'm going to find my rate by dividing. And and I always like to do 2 of them if they give me 3 terms just to make sure. That's -110. I'll definitely won't get the same ratio if I copy down the numbers wrong. Okay, so now I can tell my R is 0.95, negative 95. So now I'm going to write my formula. And then I want to use my formula to find a sub 11, my 11th term. And I know this is going to be probably a pretty big decimal. I'm going to have to round it a little bit. I'm going to do 2 decimal places. So when I plug this into my calculator, make sure that you raise it to the power first. And I know that 0.95 to the 10th should be positive, so I probably wouldn't even put the negative in my calculator. I would just do 0.95 to the 10th, multiplied by negative 122. And we get about negative 73.05. So for the next one, we're looking at geometric means. So arithmetic means was like basically those numbers that it would take to fill in that pattern so that we would have an arithmetic sequence. So kind of the same thing today, it's just now we're looking at a geometric pattern. So basically we don't know R, but we want to have 3 numbers in here so that we have an R that works and we can get all the way from A1 at 264 to A sub 5 at 1.03125 so that we know we have 5 terms, but we don't know what our R is, so we can't build in those other terms yet. So our job is going to be to find R and then multiply by that so that we go from 264 to 1.03125. So kind of the same idea we did yesterday, but now we're working with a geometric mean instead of an arithmetic mean. So we're going to have that geometric formula. So I'm going to go ahead and write it down. And we're going to have to use this to solve for R. And so I'm going to use A sub 5, because I know my 5th term. A sub 1 is 264. R is what I'm going to need to find. And my n would be 5 minus 1 then. So what I can do is I can substitute for A sub 5, that 1.03125. I will have to divide both sides by 264. And I'm not going to actually divide it out because it's going to be a big fraction. I want this to be as accurate as possible, so I'm going to plug in this giant fraction. 4th power means a 4th root on both sides. And remember, that means if I have that even root, even power, and then I take a root that I could have an absolute value. And that would make sense for our pattern, right? We know when we multiply by a negative, it's going to alternate between negative and positive. And that could work for our pattern. We could have a positive 264, then a negative, then another positive number, then a negative, and that would give us that positive number at the end. So we don't know if R is positive or negative. And when I plug all this into my calculator, I get 1/4. So I'm glad that I did not round, because then I would have been rounding again. I might not have realized it was just 1/4. So it's simplified very nicely. That means R is positive or negative 1/4. So now to fill in the blanks and write out my my sequence, my geometric sequence. So I start with 264, and then to fill in those blanks, I'd multiply by 1/4. So that's 60, or yes, 1/4 is 66, multiply by a 4th again, and I get 16.5, multiply by a 4th again, 4.125, and then my last term is 1.03125. So if I let R be negative, then that's going to change and make the 66 negative. And then I multiply by negative again, I get positive. And then I multiply again, I get a negative. And then a positive, of course, at the end. So when we find a geometric mean, we're just really trying to fill in the blanks so that we have an R that takes us from one term to the next. And we're basically just building a sequence. And we needed to figure out what those numbers were in between in order to have that sequence. So we also need to look at, of course, series. So you see that we're kind of following exactly what we did yesterday with arithmetic sequence, where we learned about this, what a sequence was and how to recognize it. We learned how to write a formula for them. We learned about the means, and now we're going to look at series. So series again is sum, an indicated sum. So sum of the terms of a geometric sequence. And we have different ways of finding that out. I really prefer Formula 1. So it means that I only need A1. I do need to know my n. I need to know r to the nth power, but I normally use this one. I'm sure there are situations where you might prefer the second one, and sometimes on some of my problems, just to be sure of my answer, I'll use both formulas. But I find I just tend to gravitate towards that first one. Just a personal preference, I guess. So for 6a and b, we're going to be actually using these formulas now. So this says I want to find my first 11 terms, and I know the first 3 terms, but I don't know anything else. So I think it would be good if I started by writing down that formula. So S sub n equals A1 times 1 minus r to the nth over 1 minus r. So let's think about what information I need. Well, I need A1, and I have that. A1 is 4. I need n, and if I am figuring out the sum of 11 terms, then n equals 11. But I don't know r, so that's the last thing I have to find. So to get r, I'm going to take -6 and divide by 4. And that gives me a -1.5. And I could just double check it and take 9 divided by -6. I get the same thing. So now I have everything I need to plug in here. So S sub, really it's 11, right? We're adding 11 terms, equals 4 times 1 minus, got to have parentheses because I'm raising this to the nth power, -1.5. So that's going to be 11th power over 1 minus -1.5. So lots of negative stuff here I'm going to have to kind of work out. So I'm going to go through and do that now. So in the numerator, if I have 1.5 to the 11th power, it's going to end up being a negative. And so I'm going to end up having a plus here. So I'm going to write this as 1 plus 1.5 to the 11th. I'm trying to just kind of simplify how I put this into my calculator. And in my denominator, the 1 minus -1.5, I can just add, it'll be 2.5. So now that I have simplified kind of how to put this into my calculator, I don't have to have as many parentheses. I am going to go ahead and just calculator it at this point because I know that 1.5 to the 11th is not going to be a nice, neat number. I'm going to have a decimal anyway. And I get approximately 140. So on the next one, we're given some information again. We have a sub 1, a sub n, and r. And I need to find the sum of the first n terms. So I'm finding s sub n again. And my formula is a sub 1 times 1 minus r to the nth over 1 minus r. So on this one, I don't know that nth power. So let me look at that other formula and just make sure that it doesn't have something better. So sometimes that's what we have to do. I could find the nth power, right? I could go through and I could use my formula for a geometric series and I could work that way. But if I have all the information for the second one, then I might just use that instead. So I do have my A1, I have my AN, I have my R. It looks like I'm going to use that second formula. So right after I told you that I like the first one better, now here we are using the second one. So just pay attention to what information you're given. So S sub n is A1, so -4, minus A sub n, -65,536. We'll do parentheses there, times 2. All over 1 minus r, so 1 minus 2. And just to set the record straight, we could use that first formula. We would just have to find n first. We would have to use our formula to find n and then work backwards. If I have a negative times this 2, and then I have a minus sign there, I know I'm going to be adding. And the 65,536 times 2 would be 131,072. And this is all over -1 now. And so when I add and then change my sign, I'll have negative 131,068. So we actually found the sum of the first n terms without even having to know n. So for 7, now we're looking at a geometric series again. Remember, this is our summation notation, so we're adding over and over and over again. If we're starting and we're going from 3 to 8, remember that means we're going to find a sub 3 plus a sub 4 plus a sub 5 plus a 6 plus a 7 plus a 8. So we're not actually adding. We can't get n does not equal the point I'm trying to make, n 8 minus 3. That doesn't work, remember? Because we have to count our first term and our last term. So 1, 2, 3, 4, 5. Our n is really 6 here. It's not 5. So if you're going to subtract, you have to remember that, and you always have to kind of offset that and add that 1. So I know I have 6 terms. Looking at this, my rate is the one in my parentheses. So my r equals -2. And I know it's really tempting to look at this and say, well, this is a sub 1, but I'm not starting adding with that. So it's not really my a sub 1. I need to find what this thing is. And you can call it a sub 1 or you can call it a sub 3, but I need to find the first term of the stuff I'm adding. I'm going to call it a1. And I'm going to erase some of this junk to get it out of the way. And I'm going to call it a sub 1 because it's the first term I'm adding. And in my summation formula, it's going to be a sub 1. So I'm going to label this first term I am adding. It's going to be when my n equals 3. And if I think about that summation formula, I'm going to go back to the one I really like. It has an a1 right here. And that's really the first term I'm adding. So in this case, it's not really a1. It's almost like a sub 3. But I want to just call it a1 because it's an a1 over here. So the first term I'm adding will be -2 times -2 to the n is 3, 3 minus 1. Oh, 3 minus 1 is a +2. -2 squared would be a +4. -2 times 4 would be an 8. So my first term that I'm adding starts when n equals 3, and it ends up being 8. And then 1 minus my rate we said was a -2. I'm adding 6 terms together. My denominator is 1 minus -2. Just back on this A1 versus A3 thing, if you wanted to make both of these A3, that could work as well. Just remember, it's the first term of the stuff you're adding. So now I have to simplify this. 2 to the 6th power is 64. And because it's an even, it'll just stay a +64. So 1 minus that +64. In my denominator, 1 plus 2 is 3. And now I have, oh, this was a -8. Almost dropped that. So -8, -8. I knew there was something wrong. 1 minus 64 is -63 over 3. Looking at this, I know it's divisible, so I'm going to keep just working without a calculator. 168, I'm pretty sure, +168. So there's our sum. We're also going to look at sum of an infinite series. The problem is if the absolute value of my rate is less than 1, I'm converging on something and I can find the sum. But if my rate is greater than 1 and my limit goes off to infinity, I can't really add something that has an infinite number of terms. I can only do that when each of those successive terms is getting closer and closer to something. only if there's really a limit. So we have to look at R. So for A, 18 divided by 24, what is that? Divide by 6, 3/4, so this is 0.75. And then if I grab a calculator and double check 13.5 over 18, I have 0.75, so my R is less than 1. So I can find my limit here. And then I'm going to use this formula. So this is for an infinite series. The other one, we were adding a certain number of terms. Now we're finding an infinite, sum of an infinite series. So a sub 1 is 24, and then over 1 minus r. So 1 minus, I'm going to write this as 3/4, which is 1/4. 24 divided by 1/4 is the same thing as 24 times 4 over 1. So I end up with 96. And for some reason I wrote 98. So let's fix that. So 96. For B, when I divide successive terms, 0.66 divided by 0.33, my R is equal to 2. And so that means I will have no sum. The sum does not exist because my function just keeps growing and growing and growing. There's really no way to add. They're not going to get closer and closer to a number so that I'm able to actually figure that out. For my last one, my R is 0.65, so this one's looking good so far. It starts when n equals 2. So this is another one of those weird things where I find my a sub 1. I need that for my formula, right? A sub 1 over 1 minus r. It's really where my n equals 2. So 3 times 0.65 times, or 2, the raised to the 2 minus 1 power. So 0.65 to the first power. So that is equal to, grabbing a calculator here, 1.95. So my sum is going to be 1.95 over 1 minus 0.65. So let's go ahead and subtract. That's 0.35. So I'm noticing numerator and denominator 2 decimal places. I always prefer to have a fraction. It's going to be more accurate. I'm going to call this 195 over 35 and then divide top and bottom by 5 to reduce. So that's going to be 39/7. Fractions are always going to give you an exact answer. We really prefer to not have those decimals. This is it for our 10-3 notes.